All right, let's dive in. Today, we're not just looking at data, we are stepping directly into a digital crime scene. We're going on an investigation, hunting for clues left behind by intruders. But these clues aren't fingerprints or footprints, they're hidden in the most fleeting place possible, a computer's memory.
So what can we actually find in there? I mean, think about it for a second. We're talking running programs, open files, active network connections, even passwords that were typed just moments ago. It is an absolute treasure trove of evidence, a digital ghost of the system's past activity. And today, we're going to become ghost hunters.
The main piece of evidence we're working with is called a memory dump. You can think of it like a snapshot, a perfect freeze frame of a computer's RAM at the very instant something went wrong. And our job as the detectives here is to piece together the entire story of the crime from this single, frozen moment in time. To do that, we first need to understand the rules of the game, the principles of our investigation. So let's start by defining the core concept we're working with here. This is it, memory forensics. It's all about analyzing that volatile memory, the computer's short-term workspace. Now, the key word here is volatile. Unlike the data on your hard drive, this information vanishes the second you power down the machine. Poof, it's gone. We're working with evidence that is literally designed to disappear. That memory dump isn't just a file, it really is like a photograph. Every single process, every network connection, every little piece of data is frozen in place just as it was. Our job is to develop this photo and find the clues that are hidden within it. Of course, every detective needs a toolkit, and ours is one of the most powerful in the field, Volatility 2. This is our magnifying glass, our fingerprint kit, and our chemical analyzer all rolled into one incredible package. It's the framework that's going to allow us to make sense of the absolute chaos inside that memory dump. So, our investigation begins. But before we can start looking for clues, we have to understand the crime scene itself. We can't just barge in. We need to know exactly what kind of environment we're dealing with. We have our evidence, that memory dump file. The very first thing we have to do is identify the system it came from. Was it Windows 10? An older version? Was it 64-bit or 32-bit? Literally every other step we're about to take depends on getting this right. We do this with the imageinfo command. This is kind of like a detective identifying the make and model of a door before even trying to pick the lock. Volatility analyzes the dump and suggests a profile. It's basically a blueprint that tells it how to correctly interpret all the data for that specific operating system. If we use the wrong profile, all that evidence is just going to look like gibberish. Okay, now that we've profiled the environment, we can move from the where to the who. We need a list of everything that was active on this system at the time of the incident. These are all of our potential suspects. We start with PS list. This is like asking for a lineup of every single program running on the machine. Then we use PS tree to see their relationships. This shows us which process launched another, kind of like building a family tree. Is cmd.ext being launched by an Office document? Well, that's incredibly suspicious, and PS3 helps us spot it immediately. Of course, the clever attackers aren't just going to stand out in the open waiting to be caught. Sophisticated malware is specifically designed to be invisible, to hide itself from the operating system's normal view. And this is where true forensic tools really shine. A standard tool shows you what the system wants you to see, but PSEXView cross-references multiple different methods for finding processes. When it finds a mismatch, that's our hidden suspect. It's a process trying to cloak itself, and we've just caught it red-handed. So we have a suspect, that hidden process we found with PXView. Now we need to find out what they did. It's time to trace their digital footprints and reconstruct their actions step by step. The CMD scan command is an absolutely incredible place to start. It scours memory for any commands that were typed into the command prompt. This is the digital equivalent of finding the attacker's handwritten notes at the crime scene, showing us exactly what they were trying to do. Attackers are almost always after something: data, passwords, sensitive information. So another angle of our investigation is to see what they might have been trying to steal. And this is where we check the clipboard. Oh, it is a goldmine. The clipboard command can pull out the last thing that was copied on the system. Was it a password? A private key? A secret URL? This tiny piece of evidence can blow a case wide open.
You know, digital crimes rarely happen in a vacuum. The malware on our system is probably communicating with its master, a command and control server somewhere out on the internet. We need to trace those lines of communication. For that, we use NetScan. This command is like getting the phone records for the system. It shows us all the active and recent network connections. By looking through this list, we can often find the suspicious IP address the malware was calling home to, giving us a crucial piece of the attacker's infrastructure. All right, we've identified a suspect and we've traced their actions. Now it's time to bag the hard evidence, the digital artifacts that will prove the crime and allow us to analyze the attacker's tools directly. Using the procdump command, we can reach right into memory and pull out the exact executable file of the malicious process. This is like finding the murder weapon at the crime scene. Now we have the actual malware file, which we can reverse engineer and analyze to understand its full capabilities. What if the attacker was trying to gain more access? With hashdump, we can extract the system's password hashes directly from memory. This is like finding the attacker's lockpick kit and a copy of every key to every door in the building. It shows us their intent and the potential damage they could do. And for the final, most incredible piece of evidence, we can literally see through the attacker's eyes. The screenshot command can reconstruct the user's desktop from the data lingering in memory. We can generate an image of exactly what was on the screen, providing undeniable visual proof of their activity. Which brings us to our final thought. After seeing that we can recover commands, passwords, and even screenshots from the supposedly empty space of a computer's memory, it really makes you wonder, in the digital world, is anything ever truly gone for good?